This problem we have a two-column proof, and it's asking us to prove that the measured angle EFD is equal to 90 if we're given that EF is perpendicular to FD. So that line, or this symbol I should say, with kind of a line and then it's almost like an upside down T. That means perpendicular. And remember, when you have a proof like this that's completely blank, you can start by filling out a few things that kind of go in these automatic slots. First off, we're going to put our given, which is EF, in the first line here. I'm going to say that line segment EF is perpendicular to line segment FD. All right. The reason that I can say that, the reason here is going to be given. They gave that to us. So usually this first one is always going to be given, and we write down what that given thing is. Just like the last line, what we're trying to prove, once I have proved that, we're going to be done. So this is going to go in the last line here, which is the measure of angle EFD. That's not FEFD. There we go. Equals 90 degrees. All right. Now, this leaves us, so we've kind of done half of it. It leaves us with three different blanks. This one, and this one. And I have to take kind of those different reasons and things and kind of prove this along the way, that if I start with something that's perpendicular, I can end up with a 90-degree angle. All right. So what did this tell us? Well, why did they give us that this was perpendicular? And what does that mean? Well, a perpendicular line segment to another one, that is going to form a right angle right here. So I have to say that that angle is right, and that angle is angle EFD. I'm going to say EFD is right. Or you can say is a right angle if you want, depending on what your teacher has you do. And the reason for that is because this was perpendicular. So oftentimes in these proofs like this, you're given words like midpoint or bisector or, in this case, perpendicular. And you're going to use kind of those words you probably only hear in math class to help you fill these parts out. They might be in this next line or sometimes even on the same line. And because this is right, I got that from being perpendicular, I'm going to say this is the definition of perpendicular angles. Definition, I'll just say definition of perpendicular. Again, your teacher might have you be more specific depending on what they have you do there, all right? So now that that's perpendicular and it tells me that this angle is right, I can use the fact that this is a right angle. So I'm going to fill it in with a box like that. That means it's a right angle. And then I can say the measure of angle EFD is 90. Well, again, just like this was the definition of a perpendicular angle, this is going to be the definition of a right angle. All right angles are 90 degrees. So I can fill this one out with the definition of a right angle. And because of that, right, this is 90 degrees. I have finished the proof and I am now done. I have proved that EFD is 90 based off of the fact that EF was perpendicular to FD. All right, hopefully this video helped you out. And until next time, keep doing your math homework fast and accurately.